Today we're going to introduce a new type of equation, which is the absolute value function. An absolute value is often referred to as the magnitude or size of a number. If you are studying physics, for example, you would learn that if I said something was 10 kilometers away, that is the distance or the magnitude that I have traveled, but there is also another component of that, which would be the direction. In maths, to have direction, we have positive numbers and we have negative numbers. But an absolute value wants us just to take the magnitude or the size of a number, which means that the absolute value sign will take away any negative signs. So an absolute value is like a distance without a direction. The absolute value of an integer is its distance from the zero on a number line. The notation absolute value of x is used for the absolute value of an unknown integer that satisfies a given condition. So those little lines on either side, they mean absolute value, and anything that is inside those absolute value sign will be made positive. The total will be made positive. So there's a definition here of the absolute value of x. Now, what could x have been? If x is a value that was larger than 0, then it would have been a positive value of x that we started with. But if it was less than 0, we actually could have had a negative x inside those absolute value signs, but the absolute value sign makes it positive. And here is an example seeing it with numbers. The absolute value of -5 means that we just want the positive 5, we just want the positive distance. So on the number line down here, the first dot here is at -5. When I take the absolute value, it is a positive 5. Now each of these two dots are both 5 spaces away from 0, which is the center, so they have the same magnitude, the same size. The absolute value of 3 is still a positive 3. We don't turn it into negative. The absolute value sign just always makes it positive. So absolute value of 3 is still 3. There is a whole bunch of absolute value properties which are listed here. The absolute value of A times B would be the same as absolute value of A times absolute value of B, because it wouldn't matter if either one of those was negative, they would both become positive numbers, and we could just multiply the magnitude of those positive numbers. If you square anything in absolute values, it's the same as A squared, because even if it was negative, it's going to become positive anyway. Square root of A squared is going to be the same as the absolute value of A, because we can only square it positive numbers anyway, so we know that that's going to be positive. The absolute value of negative A, because the absolute values take the minus sign away, that is the same as the absolute value of A. If you're going to subtract two numbers, A minus B would be the same as B minus A, because if you subtract them in a different order, it just means that one of them would give you a negative sign, but again, the absolute value signs would take care of that. And absolute value of A over B would be the same as having absolute value of A over the absolute value of B. That's pretty much along the same lines as property number 1 when we were multiplying. It works as well for dividing. Okay, so here's some questions like you're going to have to do. First of all, we just want to start with normal numbers inside our absolute value signs. So if I want to find the absolute value of 7, the absolute value sign means I want to take away that minus sign, and it's just equal to 7. The absolute value of 4, there's no negative sign to get rid of, it just stays as a 4. The absolute value of -1, get rid of the negative sign, is a positive 1. Part C, well, it's actually the second part C. The absolute value of -2 is what I have. The 3 is at the front of it, which means it's multiplied. So that's going to be 3 times by, but when I take the absolute value of a negative number, it becomes positive. So 3 times +2 which is 6. So the absolute value signs do behave a little bit like brackets, but just needs to make whatever's in there positive. In the next one, we have absolute value of 7 and absolute value of -1. So absolute value of -7 is a positive 7. Then I have +4, and that will be times by the absolute value of -1, which is a positive 1. 7 plus 4 times 1 makes 11. And absolute value of -2 and absolute value of -6, I need to deal with those first. -2 will become a +2. The -3, because it's not in absolute values, it will stay negative, and that will be times by a positive 6 from that second absolute value sign. 3 times 6 is 18, and 2 take away 18 is -16. In question 2, because we've been doing lots of different types of graphs, we would like to know what the graph of an absolute value function looks like as well. So the key thing with each of these graphs is to find where the point is going to be of them. Now each one of these, because you haven't seen them before, is going to be a graph that comes down, has a point, and is going to go back up again. And we need to find that pointy bit to start with. Now this very first one, the y equals absolute value of x, this would be our very base model, like our y equals x squared parabola is what we base everything on. This would be what you would base the absolute value graph on. The vertex for this one it is at the origin. So right here. Then, because I need to know the steepness of those two arms coming away from there, I would need to sub in a value on either side of that. So let's sub in a +1 and a -1. When I put +1 into my absolute value sign up here, absolute value of 1 is 1. So that goes here. The absolute value of -1 is a +1 for there. And then we connect that up. Okay, so there is our base absolute value graph. From that, we want to be able to move it sideways and up and down. So if I have got an x plus 2 inside here, that means I'm going to be moving that point sideways or to the left 2 spaces so that it is at -2. Okay, so -2 goes there. That's where my point's going to be. Because I've now moved the point off to the side, I would want to find the y-intercept for this graph. So I would sub in x equals 0. 0 plus 2 is 2. Absolute value of 2 is still 2, so there it is. Because these graphs are symmetrical, if we go 2 spaces on the other side of that point, so to -4, that would also be at a height of 2. And there is the whole graph. Part C, because we have x minus 1 in the absolute values, that means we're going to move that 1 space to the right so that it is a +1. Okay, again I want to find the y-intercept, so I'll sub in x equals 0. 0 take away 1 is -1, but the absolute value of -1 becomes a +1. And because it's symmetrical, 1 space on the other side will also be at +1. And there it is. Part D, absolute value of x plus 1. Because that +1 is outside of the absolute value, that is going to move my exponential graph up. So my vertex, which usually starts at the origin, is going to be moved up to y equals 1. Okay, I'm going to need to find the steepness, so I'm going to plug in a value on either side of that. If I sub in 1, absolute value of 1 is 1, plus 1 makes 2. So I have that point. Because it's symmetrical, it would be 2 at -1 as well. Okay, and that one's done. Part C, I need to find where the point of that is going to be. Now, when it's a bit more complicated like this, you want to take what is in that absolute value and make it equal to 0. If I solve that, that tells me where the vertex is. So 2x equals 4 divided by 2 means I get x equals 2. So x equals a plus 2, 1, 2. That's the point. Okay, let's find our y-intercept. So we sub in x equals 0. 2 times 0 is 0, minus 4 is minus 4, but the absolute value will make that a plus 4. Because it's symmetrical, I can go 2 more spaces this way to 4, positive 4. Okay, so that one was a little bit steeper. Let's do the same thing for D. I'm going to start with the 2x plus 1 and make that equal to 0. When I solve that, I'll get 2x equals negative 1, and dividing by 2, I get x equals negative a half. So on the graph, x equals negative a half can go there. That will be the point. And again, I sub in x equals 0. So 2 times 0 is 0, plus 1 is 1. Absolute value of 1 is 1. So there it is at 1. If I go another half space on the other side, I'll be at negative 1, positive 1. Okay, so that is how you draw the graphs. Now, even though these questions didn't ask for it, there are questions that you're going to be asked to do that ask you to give the equation of the two arms of the graph that you have drawn. So this is a little bit of extra bit that I want to show you here. So what we do is we want the equation, so y equals, and there's two lines there that have joined at a point. So we're going to have one of these brackets, and we want the equation of each line. Now the gradient, this one coming up here, this positive gradient one, that equation would come directly from this equation. It is 2x plus 1. It's the positive version of what is in those absolute value signs. And you could check that. I mean, you know that 2x plus 1 is the y-intercept. Yes, it is. And the gradient is 2. Yes, that would have a gradient of 2. That equation does work for that line. The second line here is sloping in the negative direction. It is the negative version of what is inside that absolute value. And you need to change the sign of everything inside there. So it is negative 2x minus 1. Now, for that first equation, that was when x is going to be greater than negative a half. And the second equation we use when x is less than a half. Okay, and so obviously negative a half is where the point is. Let's just practice that again for the previous question, so you can see that one more time. If I want to write down the equation of those two arms, I go y equals, now my equation from here was 2x minus 4. The point was at x equals 2, so that is when x is greater than or equal to 2. The negative version, putting minus through that whole equation, would be negative 2x plus 4, so it changes the sign when x is less than 2. Okay, so just be aware that some questions are going to ask you to do that. Question 3 is similar to a question that you're going to have at the end of your exercise. This question involves sketching a graph that has two x terms in it. One of them is an absolute values and one of them isn't. So we need to do something called considering the cases of the absolute value of x. So up the top here, I'm just going to write that this is, we want the cases involving the absolute value of the x. We want to see what is happening to that. Now we know that that means that x could have been positive or x could have been negative. We also know from the practice that we've just done that the point, if we were just to draw the absolute value of x graph, would be at x equals 0. So it would be positive when x was greater than or equal to 0, and it would be negative if x was less than 0. So if we keep that in mind, we want to consider those two cases separately. So I'm going to change color here. This is what you would write down for your working. Consider separately x is greater than or equal to 0 and x is less than 0. So first one, when the x is greater than or equal to 0, that is this scenario. If x is greater than 0, that means my absolute value of x is just going to be equal to x. So using my equation over here, that means y would equal the absolute value of x is just going to be x minus the other x, and x minus x is 0. Then we want to consider the case when x is less than 0. So when x is less than 0, that's when we get a negative x from inside that inequality. Not inequality, sorry, absolute values. So that means in my equation, I would get y equals, instead of absolute value of x, it's negative x, negative another x minus another x. So that's y equals negative 2x. Okay, so we want to sketch those on our graph. So x equals 0 is going to be right here at the origin. We know that for every value of x greater than 0, y is equal to 0. So I would get a line coming out here going through y equals 0. And my x-axis and my y-axis. As soon as I go to negative values for x, I then want to sketch y equals negative 2x. Now, that means my y-intercept would be 0, which luckily it is down here, and my gradient is negative 2, which means I would rise 2 and run 1 to the negative side, and the graph would come up like that. So that is the graph drawn, which I have answered the question there, but just for further practice, let's write down what the equation of the arms would be for that graph. So we go y equals, when x is greater than 0, which was my first case up here, y was equal to 0. When x was less than 0, it was minus 2x. Okay. One more type of question, question 4. Solve the following absolute value equations. Now, remember that the absolute values mean that whatever was in there could have been positive or it could have been negative. So for this first question, that means the absolute value of x equals 3. That means x could be equal to a positive 3 or x could be equal to a negative 3. That's all that means. And that's the answer. In part B, the positive version is x minus 4 is equal to 2. Or we do x minus 4 could be equal to a negative 2. We want the positive and the negative of the number that is on the right. And we want to solve both of those equations. So adding the 4 across to the other side, x is equal to 6 is my first solution. And in this one, adding the 4 across, minus 2 plus 4 makes x equals 2. Okay, now I'll just show you that you could be asked to write that solution on a number line. So you just draw up a number line like you would for an inequalities question. And I have one solution at 2, so 3, 4, 5, 6. And you just put a dot above each one to draw the solution on a number line. Part C, do some more of these. So 2x plus 5 could be equal to a positive 9, or the 2x plus 5 could be equal to a negative 9. Solve both equations. So the first one, subtract the 5. 2x equals 4. Divide the 2, gives me x equals 2. The second equation, subtract the 5. That gives me negative 14. And divide the 2 means negative 7. If you have 2x plus 5 is equal to 0, you're only going to get one solution if they're in the absolute values there. Because 2x plus 5 equals 0, you wouldn't have 2x plus 5 equals minus 0. You don't really ever have a negative 0. So I just need to solve that one. So that's 2x equals negative 5, and then dividing by 2, we get negative 2.5. Next question. 2x plus 5 in absolute values equals negative 3. If you have something in absolute values, it can never be equal to a negative number because absolute values always makes them positive. So as soon as you see a negative over here, you're going to know that this has no solution. And you could think about that, what the graph would look like. A lot of those graphs that I drew way back here, the points were coming down and touching the x-axis and going back up again. They don't go below the x-axis unless I was to subtract something on the end like part D up here. But this question doesn't have that, and there's no way that that absolute value could ever be negative. So then we're up to D. I do 11 minus 3x is equal to a positive 5, or 11 minus 3x is equal to a negative 5. So subtracting the 11, I get 3x is equal to negative 6, and dividing by negative 3, I get a positive 2. And last one, subtract the 11, so minus 3x equals minus 16, and divide by negative 3 gives a positive 5 1/3. So that is it. There's a lot to take in, but you can now start on exercise 4D.